So today, when I read one amazing thing, I thought, gosh, there's a lot of amazing things that have happened in science, and I could probably do something about those. So we're going to talk today about the wonders of scientific discovery. And what I'm talking about really are scientific breakthroughs. For example, how are scientific breakthroughs made? A lot of times it's just a long process of gathering data and then figuring out what they mean. But sometimes there's an epiphany, an amazing insight that blazes the way. Today we're going to look at some insights in biology, geology, chemistry, and epidemiology and public health. Amazing insights we're going to take a look at include Darwin's The Origin of Species Through Natural Selection and Evolution, Alfred Wegener's analysis of continental drift and plate tectonics. Come on. Sit. There's lots of room up front. Who put together the first periodic table. Friedrich August Kekule, The Structure of Benzene. And Jon Snow, Disease Epidemiology and Prevention. First of all, let's look at Charles Darwin. He took a 5-year voyage with a British ship called the Beagle that went around South America, made a long stop in the Galapagos Islands, and then actually cruised around around through past Australia and Africa and back to England. He observed fossils of giant creatures and living plants and animals and collected lots of natural specimens. There's an example of a specimen that he might have seen on the Galapagos Islands. He was intrigued by the diversion of species in the isolated Galapagos Islands. If you're not aware of them, they sit several hundred miles off the coast of Ecuador. And actually, because of the way it's shaped, they're actually almost directly underneath Miami. There's a chain of several different islands, and what he found was that creatures on some of the different islands were different. The birds, particularly finches, and the tortoises he saw were different on each island. So his theory is, how could these different beaked birds become different? The islands are too far from South America for the finches to have flown from there, which is what a person might say, okay, well, they didn't start there. They came from somewhere else. Well, it was too far away for them to come from somewhere else. And notice here we have 9 different beaks for the birds. And they're all, some are ground finches. They have crushing beaks. Some have probing beaks. Some have grasping beaks. And one has a beak like a parrot. How did that happen? So he went home, he took a specimen and note home and tried to understand why the animals were different. Then he had an idea. He said, what if those differences were caused by natural selection? That those animals who changed in the different environment were more successful in it. And that's what we call evolution. That the ones that are more successful beat out the ones that are less successful. So if you've got if you build a better mousetrap, people will build a better mousetrap, people will beat their way to your door. If you build a better bird, you will do better. So the other thing, some of the unusual species he saw on the Galapagos include marine iguanas. What are iguanas? Iguanas are lizards. Where do lizards live? They live on land. So why? Well, one of the reasons, that if you know about the Galapagos, is that the land doesn't really provide very much. Where's the richness of food and diversity? It's in the water. So the iguanas adapted. Who was the first brave iguana that jumped into the water and said, I'm going to eat algae right there? So that's what they do. And they also have flightless cormorants. So we have birds that don't fly. Because why? Because they're swimming instead. They don't need to fly, they go into the water instead. Now, Alfred Wegener, landmass movements. So we think of continents as fixed masses on the surface of the globe. Because for us they are. I mean, they haven't moved that we can tell in our lifetime. Probably not in generations. But this daring meteorologist had a different thought. So he looked at South America and Africa, and he noticed that the coastlines match up. So if you took South America and you just went crunch it into the side of Africa, it would fit. Probably a lot of grade school kids did the same thing, and the teacher said, "Oh, you're crazy." But he didn't. He also noticed that plants and animals were very similar on the two continents. So I've got a palm tree there and then bugs and all that sort of stuff. That they were similar. As if those two continents had been together at some point in the past. And so there were similar plants and animals there. So here's Wegener. He concluded that the continents had moved, separating sometime in the distant past, South America and Africa sometime in the distant past. Now, what did they think of him? Everyone else thought he was a fool. Now, also, you have to realize there's some... he wasn't a geologist. He was a meteorologist. So they said, "Oh, you're not even in our field. What do you know?" Well, he was right. And today we understand that tectonic plates float on the surface of the planet and the continents move with them. Does anybody know what those things are? Elements. So this is people so we go back to chemistry here. In the 1700s and 1800s, a quest was on to find new chemical elements. At the same time, chemists noticed that some elements had very similar characteristics. In fact, these two here, sodium and potassium, actually, were very similar. So there was a plan here now, there's a challenge here now to assemble them into orderly groups. So we come to the Russian chemist Dmitri Mendeleev. Very, very studious man. Here he is in his giant library. He's got tons of books. Okay, move up. So he studied, at the time there were only 63 known elements. He considered various ways of organizing the elements together. So his first periodic table put the elements in ascending order of atomic weight and grouped them by similarity of properties. So that makes sense too. You start with the smaller ones and you build them all to put them together. The smart part really was putting the similarity of the properties together, because that explains why they're similar. He predicted the existence, not only the existence, but the properties of new elements based on their location in the periodic table he designed. One such example was gallium, which is one step up from aluminum. He predicted that it would have similar characteristics to aluminum. He predicted what temperature it would melt at, what it would combine with, what it would look like. And that's why we have the periodic table today. Again, it starts off here is hydrogen. So these go in increasing atomic number. But what he did was so intelligent is he said, these ones all have similar properties, so I'm going to put them together. The same thing with the ones over there. So gallium, here's aluminum right here, with gallium underneath it. He predicted the characteristics of it based on what he knew about the ones that were already that he knew that were already similar. Now, this was a long time ago, and Mendeleev, he didn't win a Nobel Prize, but he got his own element in the periodic table, which is Mendeleevium, MD. Now, the other one I'm going to talk about is benzene. Benzene is an important chemical, and many efforts were made to understand its chemical structure. It was known that benzene had 6 atoms, each of carbon and hydrogen. But each carbon atom can form bonds with 4 other atoms. This had been proven by Kekulé, it's a picture there, the leading chemist of those times. So how could you end up with 6 and 6? It didn't make any sense. So they really wanted to know. So again, carbon can bond with 4 other elements based on the number of electrons in its outer shell, as shown in the methane molecule over here. So we've got carbon in the middle, and you get 4 hydrogens around it. That's methane. In benzene, the carbon atoms were binding just 2 other atoms. This seemed to defy the rule that Kekulé had set. And said, well, how can you only have 2? You got 4 spaces. Doesn't make any sense. So what the heck was going on? So there's going to be a snake in this. I hope everyone doesn't mind. So once while thinking about the problem, he nodded off and he had a daydream. And then he saw a snake coil up and suddenly grab its own tail. It then struck him that benzene's structure might be a ring. And so it was. Benzene is a ring structure in which there are two double bonds here between the 2 carbons. So it's 1, 2, there's 1, 2, 3, 4, 1, 2, 3, 4. And actually these electrons here kind of go around in a big circle. And Kekulé said, let us learn to dream, then perhaps we will find the truth. Finally, I'll take you to one personal case that means a lot to me because I have a degree, I'm a Master of Public Health. And this is a good story. I take you back. This is the 1850s. The microbial world is unknown. Nobody knows about bugs. The only bugs they know are the large ones. Microbia, they don't know about any kind of disease-causing organisms. Water pollution now is an unrecognized fact of life. And waterborne epidemics were common, particularly the dread diarrheal disease cholera. There's a story going on that you could go in your carriage, ride in your carriage into Regent Park, and by the time you got from one end of Regent Park to the other, you'd be dead because the diarrhea would have occurred so fast. Now, I don't know if that's true or not, but it turns out that cholera was a very violent diarrheal disease. So, but Snow was watching all this, but he couldn't convince other doctors and scientists that cholera was spread when the people drank contaminated water, which still happens in the developing world. Then a mother washed her baby's diaper in a town well in 1854 and touched off an epidemic that killed 616 people. Earlier, in 1850, London residents would get their water from pumps located on the street. And what Snow did, and this is a classic case of geographical epidemiology, in that what he did was he would get the records from the city of deaths from cholera, and he would plot them by addresses in the city. So he would see that in this building there were 2 deaths here, there were quite a few deaths here, 5 or 6 deaths there. And this is all along a street called Broad Street. This is Broad Street. So what just strikes you about this is where all the deaths seem to be clustering around one particular area or one particular star right there, doesn't it? And indeed, that's the case. Plotted the deaths in Soho. He noticed they clustered about one pump, the pump on Broad Street. So that's the pumps. And these are all the other pumps. That's what all the blue dots are pumps a pump on Broad Street. Dr. Snow persuaded the town council to remove the pump handle, stopping the epidemic in its tracks. Actually, the story the epidemiologist told us that he actually stole a pump handle. And Dr. Jon Snow is considered the father of epidemiology. So, as you can see from the examples I've given, sometimes scientists work hard and slog hard and put all stuff together and they figure it all out. What these scientists did was look at something and say, you know, I think I see how that could work. I think I see how the continents could have moved. I see how those animals became different. I see how I can stop an epidemic. So that's the amazing part of science to me, is looking at something and saying, oh, I see how this works. I see how this fits. Scientists have a curiosity. They want to know why. And they spend their whole lives doing that and having a great time doing it. Thank you.